The giant or large molecule formed by repeated linkage of small molecule are known as macromolecules. Polymers are also macromolecules. Let us take an example. Ethylene, as you know, it contains 6 atoms. But polyethylene, here if N is equal to 500, then 3000 atoms will be there. That means this is a big molecule. So here N is nothing but degree of polymerization, which is nothing but how many times number of repeated linkage are present in a polymer. Those macromolecules which are found in nature or isolated from natural materials are known as natural macromolecules. And here are the few examples. Proteins. As you know, in proteins, peptide linkage is present. Proteins are made up from 21 different amino acids. Second example is of carbohydrates. Nucleic acid, that is DNA and RNA. Natural rubber is also an example of macromolecules, which is obtained from the latex of rubber tree. Then here are the examples of synthetic macromolecules. As you know, synthetic macromolecules are also known as artificial macromolecules. These are nothing but man-made macromolecules. And examples are polyethylene, polyvinyl chloride, polyesters, nylons, bakelite, synthetic rubbers like Bunaeus, Bunayan, neoprene rubber, etc. Now next point is molecular weight of macromolecule. Molecular weight of simple molecule is fixed. For example, molecular weight of ethylene is 28 gram. But in case of macromolecule, molecular weight is not fixed. Let us take an example of poly. You see here in polyethylene, if value of N is 500, molecular weight is 14,000 gram. Whereas if value of N is 550, then molecular weight is 15,400 grams. Whereas value of N is if 600, then molecular weight is 16,800 grams. Thus molecular weight of macromolecule is not fixed, and thus it is expressed in terms of average. So in terms of average, molecular weights are expressed in first, number average molecular weight, second, weight average molecular weight, third, viscosity average molecular weight, and fourth, Z average molecular weight. Now let us discuss one by one. First is number average molecular weight. Now let us suppose that N1 is a number of molecules having molecular weight M1. N2 is a number of molecules having molecular weight M2 and so on. Let me explain to you this one. Here you see value of N is 500, so molecular weight is 14,000. So let us suppose that 10 are the number of molecules having molecular weight 14,000. 20 are the number of molecules having molecular weight 15,400. So like this, that is N1 is a number of molecule having molecular weight M1 and so on. So weight due to first fraction is equal to W1 is equal to N1 into M1, because if 10 molecules are present with molecular weight 14,000, then weight of that kind of chain is 14,000 into 10. That means W1 is equal to N1 into M1. So weight due to second fraction is equal to W2 is equal to N2 into M2 and so on. Now how to calculate average? So that average, it is known as number average molecular weight, which is nothing but weight of all macromolecules divided by number of macromolecules. So it is equal to N1M1 plus N2M2 plus so on divided by N1 plus N2 and so on, which is nothing but summation of NIMI divided by summation of NI. Second is weight average molecular weight. So as you know, number average molecular weight is given by expression summation of NIMI divided by summation NI. So replace here number by weight. So therefore, weight average molecular weight is equal to W1 into M1, because here N1 is replaced by W1 plus W2 into M2 and so on divided by W1 plus W2 and so on. Now you know that W1 is nothing but N1 into M1, W2 is nothing but N2 into M2 and so on. So put those values. So final expression becomes summation NIMI square divided by summation NIMI. So these are the usual numericals which are asked on this topic. Thank you for watching this video.